Welcome back. This is Inc. And in today's problem, we're going to calculate the value of each resistor. And that value that we're going to calculate is going to be the per unit value. So before we do that, let's realize that the 60 ohm resistor is going to be our base resistance. So the 60 ohm is going to equal to RB, which is equal to 60 ohms. So the SI units. So when we describe SI units, right, we use that to enable. So the SI units describe the quantity of something. So it is used to specify the magnitude or quantity. If we had a big blob, we can express the magnitude or quantity of that in SI, which would be kilograms. In power, that would be watt. In voltage, that would be volts, or if you want to call it electrical potential. However, we can often get a better idea of the size of something by comparing it to the size of something similar. What that means is that we can compare RB, or let's say R1. So R1, R2, R3. So we can compare R1 to RB, right? So if I want to compare 100 to 10, I'm going to divide 100 by 10. If you see what I'm trying to say, and see what would be the result. We would know that 100 is larger because we would get something that is similar. It would be smaller if we get something in. So if it the faster it goes to zero, we know that if the numerator is smaller than the denominator, we know that the fraction goes to zero a lot faster. Anyways, let's say that might be confusing, and I might be confusing myself as well. So anyways, in effect, we can create our own unit. It's going to be arbitrary, right, to specify the size of something, of some similar quantity, and compare this to a arbitrary unit. So let's say, let's get rid of this. We're going to use RB as 60 ohms. So if we want the per unit value of each resistor, we know that the per unit, so let's just put per unit, is equal to the actual thing we want to compare divided by the base. So we want to compare the actual to the base. So in this case, if we say R1 is equal to 100 ohms, the per unit value of R1 is equal to, let's just use R1, divided by RB. R1 is 100 ohms, RB is 60 ohms. That is equal to 1.67. Same thing for R2. The per unit value of that is equal to R2 divided by RB, which gives us 50 ohms. And R3, the per unit is equal to R3 divided by RB, which gives us 0.33. And I shouldn't say ohms because the ohms and the ohms cancel out, which gives us a per unit value. So that value is a per unit value. So for instance, if you had a circuit and you say we had a circuit, just a circuit, right? And these are given as per unit. And if we are asked to combine both of those, we combine R1 and R2. That gives us our equivalent is equal to R1 plus R2. And that our equivalent would be in per unit. And let's just say it's 2. If we're asked to give the equivalent resistance as the actual value, then we would have to have the base of which we divide our actual resistors to get our per unit. So what if R1, So if that's 2, what if R1 was equal to, let's see, 2 ohms, and yeah, say both of those was equal to 2 ohms, right? That means our RB would have to equal to 2. So we know that when we divide R1 by RB, 2 divided by 2 is equal to 1. That means if we really wanted to get the equivalent resistance, or not the equivalent, if we want to get the actual value of the equivalent resistance, we would then have to use the formula we just used. So that would be R per unit is equal to the actual value divided by the base. So then if we want the actual value, we would see that the base resistance, let's just multiply that by the per unit. So in this case, to get the actual value of our equivalent resistance, we would have to say our equivalent actual is equal to the base resistance times the per unit. And as you see, that will give us 4 ohms. And in this case, if you're doing something like this, you definitely get the base. And if you don't get the base, you'd get the voltage and probably the per unit current or something for you to find the per unit, whatever quantity you'd have to find to solve an equation to figure out the actual value. So that's it for today's problem. See you in the next one. Bye.